Kleinfelder is an employee-owned science, architecture, and engineering consulting firm providing solutions to meet our world's complex infrastructure and natural resource challenges. Working as a team, our bright people will deliver the right solutions.
Engineering geology is actually a fundamental service that we've provided in Kleinfelder since the inception of our company in the Central Valley. In fact, some people may not know this, but Bud McRae, one of our first founding fathers, was an engineering geologist. So engineering geology has been with us for over 50 years and has continued to be a staple service as we've grown throughout the country and internationally. Well, I would say one of the big differentiators in engineering geology, and I'll overlap a little bit with geological engineering since they're so closely related, but a big part of what we do is to provide early on in a project an understanding of what the geologic and seismic hazards are. And the benefit of that is that we early on are able to identify what conditions need to be evaluated and what are those conditions that we need to come up with solutions for. Well, engineering geology is actually a pretty broad discipline. It ranges from everything from geologic mapping and characterization of ground conditions to fault studies and landslides and slope stability. For example, in a number of projects, whether they're dams or levees, we want to make sure that we're not dealing with an active fault or a fault that's capable of rupture, and also one that might generate a large earthquake. All of these are factors that would go into the design process that we're able to provide. Well, the classic application of engineering geology, and for that matter geological engineering, is to early on identify what the conditions are and what some of the hazards are. The importance of doing that to our client is the earlier we recognize them, the better we're able to design an efficient subsurface exploration program, testing program, and actually understanding what analyses would be required to support the kinds of designs or solutions that we would need. Well, I would say that one of the projects that stands out in my mind we did about 3 or 4 years ago. This was a project in the Bay Area that involved a landfill that was built on the side of a slope, a bluff along the ocean. And to further complicate the project, it was intersected by the San Andreas Fault, which of course is one of the most active faults in the world. So at that project, we had soil and groundwater contamination, we had slope stability issues, and then we also had the source of an earthquake and/or ground rupture along the fault. So a pretty complicated project, really combining a number of different practices. Kleinfelder was able, with their engineering geology practice as well as integrating with other practices, to bring to our client all of the services needed to not only identify early on those issues, but to better understand them and characterize them, and then finally to design mitigations to prevent further hazards from occurring. And I'm happy to report that it's still there and performing well. Well, there's a lot happening within engineering geology. There's a lot of changes in technology, and there's a lot of changes in the way in which we do our practice. I guess a couple of examples that I would share would be LIDAR is a method of imagery, and we use that to interpret the ground surface or do geomorphic interpretation. And in the last 5 to 10 years, we've been able to discover features that we normally would not. This is a technology that allows us to see through forest and vegetation, through man-made features like anthropomorphic conditions, and allow us to interpret features we were never able to see before. The other example I would give is on the risk management side. Again, in the last 5 to 10 years, risk management has become a real staple to evaluating hazards. And so when we look at geologic and seismic hazards now, we look at them in the context of risk, and that risk is really 2 pieces. It's the consequence of that hazard, and it's also understanding the probability of that hazard. Now, the benefit of this is that we're able to communicate a hazard to our client in both of those contexts, and that allows them, using their own risk tolerance, to understand what's acceptable and what's not. As a company, I think we're getting away from defining our clients' level of concern and allow them to do it as they should be.